What's up, everybody? Welcome to System Crafters. I'm David Wilson, and today we are back to our Learning Emacs Lisp series, and we're going to take a little bit more of a practical approach this time, or at least we're going to try to. And we're going to learn about buffers and what buffers have to offer to us. So let me just jump to the screen real quick, and we'll get it started. Okay, so the title of this is Reading and Writing Buffers in Practice. So why are we going to learn about buffers today? Well, you may think that buffers are just for editing text files, but you can wield Emacs Lisp to do so much more with them. You can automate the editing or even creation of files. You can create a custom display of information for a major mode. So if you look at like Magit, if you look at the dotfiles folder status for my dotfiles repo, you can see that this is a buffer, but it actually has user interface inside of it where you can expand sections. You can have key bindings that will stage chunks, etc. So the buffer in Emacs can give you the ability to make user interfaces. Also, you can use them to communicate with external programs. So if you want to launch an external process, you can read the output of that process and also write to the input of the process using buffers. And finally, you can also provide interactive interfaces like REPLs and more. So basically any REPL experience that you have in Emacs, like maybe for a Python REPL, etc., is just using a buffer, and you're typing into that buffer and pressing enter, and then that buffer information is then used to send to that process to execute something in the Python interactive shell, etc. So buffers basically are the primary user interface in Emacs. Anything that you want to do inside of a window, I suppose, is going to be mediated through a buffer. So it's really important to learn how to utilize these in your Emacs Lisp code to not only just do simple things like, remove repetition whenever you're doing file edits, etc., but it could also be for like really elaborate packages that have their own custom user interfaces. So what are we going to learn today? So in this episode, we're going to focus on the basic APIs for Emacs buffers, and then we're going to show how to read and write, read and edit buffer contents. So we're going to do this in the context of a concrete example this time, and as we've been talking about in the series so far, we've been talking about this dot file management package that I'm working on called dotcrafter. At least it's called that now because I just came up with a name for it this morning. So we are going to continue that project today, and we're going to do everything related to sort of this buffer discussion in the context of that project. Also, I've created a repository for this project in case you want to pull it down, take a look at the code, maybe try it out a little bit. It's at my personal GitHub repository GitHub account under dotcrafter.el. That's our repository name. You can follow this link here if you want to. And definitely go check out the repo and give it a star so that other people can find it more easily. All right, so in this video, we're going to update this package to add the following capabilities. First of all, we're going to automatically detect tangled configuration output files from the org mode files that we use to write our dot files. So basically, if you use Emacs a lot, you've probably heard of using the literate configuration strategy where you have an org mode file that has code blocks that have all of the pieces of configuration for different applications you use, or maybe even your whole system in the case of GNU Geeks. So we automatically tangle those files. Tangling basically means taking all the contents of those code blocks and writing them out to files in the file system. And now if we write them out to our .files folder, we need a way to sort of manage the fact that those files exist in the .files folder. So the first thing we're going to do is try to find what files are being generated by our org mode files. And then what we're going to do is we're going to update the gitignore file in our .files repository to add the tangled output files to the gitignore file so that they don't get checked into the Git repository. And I know that sounds complicated, and you're probably wondering why. Well, the goal of this package is to manage configuration files that are generated from these org mode code blocks. And then what you would normally do is generate the files into your .files folder and then symbolically link those to the actual locations where they belong in your home directory. So since they're going to be in our .files repo, we don't want to check them in because it means we have to keep those org files and output files in sync when we're checking things in, and it just becomes a headache. I used to do that for a while, and it really isn't a good idea. So what we're going to do is write some Emacs Lisp code that automatically adds these output files to our gitignore, so we don't have to worry about checking them in because Git won't even take them into account. So the code we write today will automatically update that file, and we will do it just based on the buffer APIs that we learn about and use today, which is going to be pretty fun, I think. All right, so let's talk about what a buffer is to start with. In Emacs Lisp, a buffer is an object that contains text to be displayed, edited, or manipulated. And the content of a buffer may not actually come from a file. It could be generated within Emacs. Probably you think, if you're thinking in terms of like a normal code editor, you have a file that is meant to be saved, or sorry, a buffer that's meant to be saved in a file. So like a tab in an editor, you create a new tab, but eventually you're going to save that to a file. Well, in Emacs, that's not normally the case. There's many buffers that you would never save, like the messages buffer, or even the scratch buffer, really, you probably wouldn't save it in most cases. They're just buffers that live in the process of Emacs while it's running. So the text in a buffer isn't just plain letters. It could also contain additional properties that control the font, color, size, and other factors. If you've heard of properties in text in Emacs before, then that's what this is. We'll talk about that in another episode, though, because we'll go more in depth on how to use that, basically. So in Emacs, a buffer is usually displayed by a window, like we're looking at a window right now that has this buffer for this org mode file in it. But you can also work with buffers without displaying them. There's functions you can use that will temporarily set the buffer so that you can use it in code that you're running, and then the buffer that the user has open will then be reverted back to the one that's active. And as we learned about in the video about variables, a buffer can have its own set of variables. So those buffer local variables, each buffer will have its own set of variables of its own that get applied for any code that gets run in the context of a particular buffer. So really, buffers are a very core concept of how Emacs operates, and understanding them will give you a lot of power in being able to, flesh out your own configuration or write Emacs packages. So it's a really useful thing to understand. So first of all, we need to understand what we can do to get the current buffer. Excuse me, the current buffer. So Emacs buffer manipulation functions work on the current buffer. So typically they don't take a buffer as a parameter. They're sort of expecting that the current buffer is already set. And that simplifies these APIs so we don't have to keep passing the buffer in or hold a reference to it or whatever. You can always get a reference to the current buffer by running the current buffer function. So if I were to evaluate this code with Control-X, Control-E, which you can see down here in the lower right hand that I'm doing that, the echo area will now say that this is buffer Emacs Lisp 05.org. So it basically just tells us what our current buffer is. So the current buffer in this case is not necessarily the one visible in the selected window. Like I said before, you can set the current buffer to something else that's not in the active window. So you can't really depend on current buffer being related to the one that is in the currently selected window that the user has. So you can also get buffers by name. So if you know what the name of a buffer is, you can use the getBuffer function to get a reference to that buffer. Now, you can't actually see this because I think that the asterisks are being hidden by org mode, but we're going to use this to get the scratch buffer. So I'll use Control-X, Control-E here, and then you can see in the echo area that the scratch buffer is being returned. You can also use the getBufferCreate function to look for a buffer with a particular name, and if it doesn't exist, then create one with that name that's basically an empty buffer. So in this case, I'm going to create a buffer called Hello System Crafters, and I'm running this, and also you should notice that the buffer is not being displayed. We're just creating a buffer or asking for a buffer, and it's being returned. So this is a low-level API function for buffers. So now that I've actually created the Hello System Crafters buffer because it didn't exist before, we can open the buffer list and look for Hello System Crafters, and we can see that that buffer is actually there. So Emacs has this whole list of buffers that have been opened either by the user through the use of like find file or maybe some other package that they're using, or just through the code that you've written yourself. And then, the normal buffer listing commands will show you all of those buffers. So it's kind of an interesting thing where the user actually has direct insight into the internals of what's happening in Emacs. Basically, you can switch to one of the buffers that are open. You can even switch the buffers that are open for packages that are talking to external processes. Sometimes that can be helpful for debugging issues. So it's kind of an interesting thing that you have sort of that direct access to things that are happening in the internals of Emacs. So you can change the current buffer using the setBuffer function, and that will temporarily, in theory, set the buffer that the buffer manipulation functions will then be working on. So in this case, we have a prog_n, and if you remember from an earlier episode, prog_n is basically an expression that lets you run multiple expressions inside the body. Here we are calling set buffer to set the buffer to scratch. So we're getting the current buffer of scratch, and we're setting that to be the current buffer. And then we're going to return the current buffer so we can just verify that the current buffer actually was set. So if I use Control-X, Control-E to evaluate this, you'll see in the echo area that the buffer scratch has been returned, even though our UI, our window, is currently looking at this org mode buffer. You can also pass the buffer name directly into set buffer. You don't have to use get buffer first, and we can run this with Control-X, Control-E to verify that and see that in the echo area below. However, you don't necessarily want to call set buffer to do this because it doesn't actually set the buffer back to what it was before until the current command finishes executing. So in Emacs, there's this concept of a command loop, which we'll talk about in a future episode, which basically deals with the input loop from the user. So basically when you press key bindings or run commands in Emacs with meta x, etc., whenever any of those commands is executed, that's considered like one command in the command loop. And when you call set buffer, you're basically changing the current buffer for any code that executes after your code while that main command is still running. So basically, if you call set buffer in some code and then you call the code of another package that then depends on whatever the current buffer, the current buffer is, then you're changing the expectation or you're changing the behavior because you're going to affect what their code does. They're going to operate on the wrong buffer potentially. So there are functions you can use or special forms and macros you can use to avoid problems that might be caused by doing this. One of them is called save current buffer. And basically what it does is within the scope of the code that executes within the body of the save current buffer expression, you can set the current buffer to whatever you want. You can set it multiple times. It doesn't really matter. But no matter what happens in the body of this special form, whenever it exits, it's going to set the buffer back to whatever it was before. So it's much safer. So if some code that you're writing throws an error, it will make sure, the save current buffer will make sure that the previous buffer was set back to what it was before, so that the code that runs after that is not negatively impacted. So we can test that right here by using a prog_n and saying save current buffer. And what we're going to do is set the current buffer to the scratch buffer. We're going to write out a message to say what the current buffer is. And then after save current buffer completes, we're going to evaluate current buffer again to see if the buffer actually did get set back to what we expect it to be. So I'm going to execute this with Control-X, Control-E. And we're going to pull up the messages right now. And what we can see is that the message, the message that we wrote inside of that save current buffer is writing out that we're in the scratch buffer because we set the current buffer to scratch. However, after that completes, it goes back to being the Emacs Lisp 05.org file. So that's what we expect to happen. If you want an even shorter solution, if you don't intend to call set buffer yourself, you can use the with current buffer macro, which basically just calls set buffer for you. And that will just give you like maybe like even a one-line approach to doing this. So basically you call with current buffer, you pass it the name of the buffer or maybe the buffer object that you want to set to be the current. And then in the body of that with current buffer expression, you can run whatever you want. And then after it exits, it will replace that buffer back with the one that was set before in the similar way. So we can execute this code to see that it basically has the same result where it writes out the buffer scratch, and then it says that the buffer is Emacs Lisp 05 after the with current buffer completes executing. So those two things are very helpful to make sure that you are a good citizen inside of the Emacs process and you don't set the buffer to something it shouldn't be and break everyone else's code. So oftentimes you're going to be working with buffers that actually refer to a file, because really what you want to do in a lot of cases is change the contents of a file, or maybe manipulate or create a file even. You like basically generate the contents of the file and then save it. So if Emacs created the buffer using find file or something like that, you can use the buffer file name function to get the file name associated with the current buffer. So if you see, we're currently in the Emacs Lisp 05.org file, and it basically gives us the sort of shortened output thanks to Doom mode line. But if we were to run the buffer file name, we'll see that we get the actual full absolute file path to this buffer that's currently open. And that's because this buffer has a file. If we were to go to the scratch buffer instead and run buffer current file, I'm doing that in the mini buffer below, then it's going to say, let's see, is that the right thing? Oh, buffer file name. Sorry for that. Buffer file name. it's going to say nil, and we're in messages now. So the same thing applies for the messages buffer. There's no file that's associated with the messages buffer. So when we run that in the messages buffer, it returns nil. So this is only going to return a value whenever you're in a buffer that is related to a particular file. So you can also find a buffer that represents a specific file by using the getFileBuffer function. So if you know that you want to edit a file with a particular file path, you can use this function to look up the buffer that may already exist for that file so that you can use that buffer already in case maybe the user's editing it and the file is modified and it doesn't actually reflect what's on disk. Maybe you want to edit the buffer that's currently open instead of using the contents that are on disk. So in this case, we can run the getFileBuffer function on the file name of the current buffer, basically. Since we're using the file name of the current buffer, it could be any other buffer. And it returns buffer of Emacs Lisp 05 below because it's able to find that. Now, the reason why this actually resolved to that file is because we're currently in a file inside of that same directory where we're looking for a particular file. So in case we want to prove this works, we can change this to 04 since we also have a file called Emacs Lisp 04.org. Control-X, Control-E. Oh, it actually says nil. Oh, and that's because there's no buffer open for that file currently. So that's one thing to know is that whenever you call getFileBuffer on a file path that doesn't actually have an open buffer in Emacs yet, it's going to return nil. And that's fine because really the whole point of this function is to find an existing buffer with that file. But the point I was trying to make before is that getFileBuffer is going to try to resolve that file name relative to the path that is currently in default directory. And this default directory variable, if we look at Control-HV, default directory, it basically says it's name of the default directory of the current buffer. So basically, it's usually the path where the current buffer's file lives. So in this case, it's this path where I have my notes for my streams. So you can also use a more absolute path, like in this case, we're saying in the home directory to find this whole path. This says nil though, because this notes/streams path actually isn't valid on this machine. But if I were to do this notes2/streams and run that, it's going to return the buffer Emacs Lisp 05 in the bottom. So basically, getFileBuffer is going to resolve the path that you give it before it tries to find the buffer for that file. And it will resolve it with respect to default directory of the current buffer. So let's go on with our first example on how to apply what we've been learning so far to the dotcrafter package. What we're going to do here is get the buffers for our configuration org files. I'm going to set it to the dotcrafter org files here. In fact, I think I need to evaluate the code, and I might have not actually pulled it all over here yet. Let me see. I think I can pull it up in GitHub, so just give me 1 second to pull that up. I apologize, I wasn't actually prepared for this part. So let's just see the repo, github.com/davidwill/dotcrafter.el. So this repo has all the code that we started with from the previous episode, episode number 4. So what we're gonna do is copy this, and then I'm gonna drop it into the Scratch buffer and just evaluate the code just using eval region. That way we have everything here, eval region. Okay, so now we should have this dotcrafter.files folder, which we definitely need because we're using it in the rest of the code. Okay, so that's set to my home/dot.files folder, basically. And then the dotcrafter org files is a list for all of the org file names that would be in that folder path that we would use for generating our configuration files from. So right now it's empty, but what we're going to do in the example we have here is to set it to these 3 files, emacs.org, desktop.org, and systems.org. So I'm going to evaluate this really quickly to set that list of file names. And now we have this do list, which basically does a loop over all of the items in the list of dotcrafter org files. And for each of them, it puts it in the variable org file. And now we're going to call with current buffer. Like we talked about before, if we want to set the current buffer safely, we can use with current buffer. And then we're going to pass in the buffer that comes back from getFileBuffer. It's going to expand the file name for org file to get the full file path. And it's going to expand it with respect to that dotcrafter.files folder. So we're just using simple file names here, but we want to make sure they get resolved with respect to our actual .files folder path. So that should find those open buffers for those files in our .files path. And then we're just going to write out a message saying the buffer file name, so that will tell us the whole resolve file path of the buffer that we did find. So I'm going to try to run this really quickly, and we're immediately going to see that there's an error, and that's because those files are currently not open already. So what if I just open up the emacs.org file, and maybe I will take the other two out of the list temporarily, just to show that it works if you have one that's open. So I'm going to reevaluate this code now. And now it's going to say nil, but we wrote out a message. So let's see what the message said. The message says file home davidwheel.files emacs.org. So that wrote out what we expected it to write. Now I will change that list back so that we can do the next step, which is to load a file into a buffer. So if those files are not loaded, you need a way to load the file into a buffer if you want to manipulate it. So Emacs provides a function for visiting a file. Basically, that's the idea of opening a file without displaying it as a buffer in a window, mainly for the case where you just want to load the file into a buffer to be manipulated. This function is called find file no select. So basically, it finds the file, but it doesn't actually select it in a window. So you can use this to open a particular file. In this case, I'm using it to open Emacs Lisp 01.org. So if I run Control-X, Control-E, we'll see now we get a buffer for Emacs Lisp 01. That file probably wasn't open before, so that's basically what it does. So a couple of interesting things to note about this is that if you run it more than once, it's probably going to return the same buffer of a file that's already open with that name. So it may do that for you. And if the buffer is open, for that file is open and is modified and not saved, the user might be prompted if they want to open a new buffer or not. And that can be a little bit annoying for the user, especially if you don't want them to be prompted for your automated action. So if you want to prevent them from being prompted, you can send T as a second argument, which basically says don't prompt the user. So that can be helpful if you really do just want to open the file, and if there's already a copy of it that's already open, you want to open a new copy and not reuse the existing buffer that may be modified and not reflect the contents of the file on disk at the time. It really just depends on what your use case is. In our case, we actually do care about what the current state of the open file is in Emacs, at least for now. So we're going to use find file no select if we don't find an existing buffer for that file. But if we don't find one, we're going to use find file no select. So now we can update that example to then use find file no select in that exact case, where if we don't find a buffer for the file already, we can use find file no select to pull up a buffer for that. So basically all I've updated here is the with current buffer statement. I also use a let here to expand the file name first and store it in the file path local variable so that we can pass that into both of these functions in with current buffer. So one cool thing about Emacs Lisp, or Lisp in general, is that you can use the logical expressions like or and to basically make more concise logic for certain things you want to happen. So in this case, I'm going to try to call get file buffer on that file path first, and if it returns nil, the or expression is going to call the next thing. It's going to evaluate the next expression, which is find file no select. So because or only evaluates the expressions in order, it doesn't evaluate them all at the same time before it does the evaluation, we can make this be like sort of like try multiple cases and just return as whichever one returns a value first. So if get file buffer doesn't return a value, then we would next call find file no select a file path. And this is a very Lisp idiomatic type of expression where you're being much more concise. You don't need to do like an intermediate variable. You don't need to have any if statements. You just use this or to say which things you want to happen, and if one doesn't work, just use the next one. So that's a very nice way to make this very concise and just embed it into the expression that we're using here. So one of these is going to return a buffer, and that's going to get passed to with current buffer, and then our message will be written out to say what the file is. And since we've already set that variable, or at least I think we set that variable back, let's see, dotcrafter org files. Yeah, so it currently has emacs.org, desktop.org, systems.org. So I'm going to try to run this code and see what happens. So Control-X, Control-E, and now I will look at the messages output, and we can see that we have file written out for emacs.org, desktop.org, and systems.org. And you can also see that desktop.org is now open, as is systems.org. So it opened those buffers, basically, or opened those files into buffers. So that gives us the ability to open those things and prepare for actually being able to manipulate them. So what's the point? What's the point of all this stuff that we've been talking about so far? Well, the point of talking about all this is so that we can talk about the point. And the point is actually a concept in Emacs. It's the location of the cursor in the buffer, or at least it's the location of the where any editing or navigation operation is going to be acted from in any future commands that get run or functions that get run inside of the context of that buffer. So the point is represented by an integer, which is, if you remember from the earlier episodes, that's a whole number. It's like 1, 2, 3, etc., which starts at 1, does not start at 0, starts at 1, and it increases for every character in the buffer. So if I were to go to this point function that I'm calling here, which is basically the way where you get the current point in the buffer, use Control-X, Control-E, and we see down in the echo area, it says 7330. So that's basically the integer representing the position where my cursor is right here in this buffer right now. Now, some of you are probably thinking, how do you get the line and column out of that? Well, I don't know, but Emacs knows it. So all you need to know is that if you have an integer that is from 1 to the maximum integer of the last position of the buffer, then you're good. You can start doing editing operations from there. One thing to keep in mind here is that the same buffer can be displayed in multiple windows, and the point can be different in those windows. So if I were to open another window containing the same buffer, so let's say I'm right here with point. I use Control-X, Control-E, that's 7330. But I can put the point here in this buffer, and whoops, I think that was a key binding, sorry about that. There we go. So I'm gonna put the point here, and then I'll click here in this buffer. I will, in the echo area, run point again, 7114. If I jump back to, what was that? If I jump back to this buffer again and run point again, it's 7323. So multiple windows looking at the same buffer can have different versions or different points. They have their own point. It's called the window point, and that gets applied whenever that window is focused into the buffer. So keep that in mind whenever you're thinking about this. Like if the user has their buffer open, the point may be different than what it may be in another window. So it doesn't really cause problems very much, but it's just something to keep in mind. So you can also check the minimum and maximum point locations of the current buffer using point min and point max. So typically in a buffer, if you run point min, like I do right now, it's going to return, well, okay, it's not going to do it right now, but it's typically going to return 1, and point max will return the location of the very end of the buffer. However, there is a concept called narrowing in Emacs where a buffer can be narrowed to a sub-region of the entire buffer, and the point min and point max functions will return the locations of that narrowing. So right in this case, if I evaluate this, you see that it's 6944 because this buffer has been narrowed because I'm using this presentation package called org_present to only show the current slide. So it's narrowed to that current slide. Same thing for point max. You run that and it gives you the max of the current narrowing, or if there's no narrowing, then it will give you the entire length of the buffer basically. So we'll talk more about narrowing another time, but at least for now, just know that when the user has a buffer open in a window, the narrowing may actually affect those numbers, and it could be something that matters to you. We'll look into how to disable narrowing for temporary purposes in another episode, I think. All right, so moving the point, that's a pretty useful thing to do. And it turns out that this is actually what you're doing all day long inside of Emacs when you're looking at a buffer. So there's a function called goToChar, like character, that will let you move the point to a specific integer location. So if you wanted to move the character to the beginning of the buffer, so let's see if I pull up another buffer here that actually isn't narrowed. So let's say I want to go in this desktop environment buffer, and I pull up the echo area to evaluate an expression to say goToChar1 to go to the first location in the buffer. Then it's going to jump to the cursor to the beginning of the buffer. So this will move the cursor in the active window where the user is, but also moves the point if there isn't actually a window attached to the buffer. So the buffer has its own concept of a point. So forward_char will move the point forward by a number of positions, 1 by default. So if you don't pass any parameter to it, it will just move forward by 1. But you can pass 10, you can pass 20, you can pass whatever you want. Backward character similarly moves the point backwards, and you can give it a number of positions or 1 by default. And then there's the two beginning of buffer, end of buffer functions that will move the point to the beginning or end of the buffer depending on which one you run. Those can be helpful for those operations. And we'll see in a bit that using beginning of buffer or end of buffer actually is pretty useful. So you can also move based on larger textual units. You can use the forward word and backward word functions to move based on actual word sizes, and words meaning literal textual words that are in the buffer. So we have some examples here. So if I run forward char, I will use Control-X, Control-E, and it will actually move the character forward. I can use forward char with a parameter of 5. It will move the the point 5 characters forward, which basically jumped it down to the next line and a little bit over. So it basically just follows the lines of the buffer. It will just jump down to wherever that increment is, basically. Same thing for backward char. If I go backward char by 10, it will jump to back here before. And it does actually match up to what you expect the positions to be. So right here, I'm on this position, and if I move the cursor myself 10 times, exactly where the backward char put it. So the arrow keys are messing me up here, the bindings for those here. So let me actually just quit the presentation for a second and show you. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so it puts the cursor right there before that D, right? So if I put the cursor here again and run this expression backward char, it puts it right before the D. So it makes sense, the numbering basically based on where your cursor is when you run the expression. So also forward word, backward word. I'm gonna run forward word here, and it jumps to the end of backward because backward's an actual word. So it puts the cursor after the next word basically. Also with backward word, it will put the cursor before the previous word. In this case, it just is word. So it puts the cursor right before word. So there are many of these forward backward functions, and if you want to check more of them out, you can use a function list through describe functions. So Control-H-F, and then if you type in forward, you can see there's a lot of different forward functions that you could use here that might be helpful for your purposes. Also the similar thing for backward functions. And the cool thing about these functions is they're basically the same ones that you use with the Emacs default key bindings all day long. Like if you're using, I don't know, what is it, control, let's see. I don't remember what they are, but let's see if I drop into Emacs mode, Control B, yeah, look down here at the readout. Control B goes to backward char, Control P goes to previous line, Control N goes to next line. I think Control F goes forward char. So basically, the key bindings in Emacs are actually calling these same functions. So you can use the exact same movements basically that you use in the editor to script the editor to do any kind of edits you want to do. So that's actually a pretty cool thing about Emacs. You know, everything that Emacs can do, you can do basically, and vice versa. All right. So one thing you need to do a lot whenever you're moving the point around in code is to preserve the point. So similarly to how we were saving the current buffer before changing it, we also want to save the current point before we change it so we can put it back where it was in case the user has that buffer open and visible. So if you don't do this, then basically you're going to move the point for the user, and they're going to wonder why all of a sudden their cursor jumped down to the bottom of the screen. So you definitely want to use this save excursion special form, which basically saves the location of the point, and then you can move it to wherever you want, as many times as you want, and then whenever the body of this save excursion exits, it's going to set the point back to where it was before. Excuse me. So basically the same idea as the with current buffer. If there's an error or anything that happens there that causes the code to exit early, it's still going to go and put the point back where it belongs. So it's a very useful thing to do this. All right, so now let's talk about examining buffer text. So now that we know that we can move the point around, let's figure out how we can actually find what text is at the point where we put the point, basically. The most basic way to do this is use the char after function, and what that does is give you the character after where the cursor is currently. So basically, if my character is here right before this H, char after is going to return H, and we can run that in the mini buffer here, char after, and it's going to return H. What you see here is 104, but if you look at the readout here, the actual character representation of 104 is H, basically. So you can also, by default, it gives you the current point or uses the current point, but you can also pass in a point location if you want to read the character at a particular point. Maybe if you're doing some math based on where the point currently is, and you want to just read the characters without actually moving the point more to read them. So you can also get a substring of text in a buffer by between 2 point locations using the buffer substring and buffer substring no properties functions. So I'm going to use buffer substring to get the text between positions 1 to 21 in this buffer. I'm going to use Control X, Control E. Args out of range. I think that's because I'm actually in a narrowed region. So let's actually see what point tells me right now. Or actually, no, point min. I'm going to run point min. And it's going to tell me 9328. So 9328. And 21 after that is what? 49. So 9349. All right, so I'm going to run this right now. Buffer substring. All right, now what we see here is it returns us a vector, and we know this is a vector or an array basically because it is an expression that starts with the hash symbol basically. So hash open paren, and then it has basically a bunch of entries that are members of this vector. The first thing is the actual text that is at that location. So we see examining buffer TE. So it basically takes the very beginning of this heading because this is where that point location is. And then after it, it's got a whole bunch of other stuff here, mainly talking about what font faces or what properties are being applied to the text to make it have the colorization, the font size, etc. So this is why the buffer substring no properties function exists, basically to make it so you can get the string without all that extra information. Sometimes you do want that information, but many times you do not want it. So if I were to use the same locations and run that, we'll just get the string that is at that range location basically. So good thing to know, you can basically grab text from the buffer without any of that extra formatting information and then just use the string directly. All right, let's talk about the thing. This is actually a really useful thing that is built into Emacs. It's a function called thing@point. And basically what it does is uses some internal patterns to grab some kind of range of text based on a thing that you might be looking for. So in this case, it could be like a word, a sentence, or a line. It could be a full S expression in Lisp code, or even a list in Lisp code, and even a function definition in Lisp code. So it's very useful if you're trying to do some editing functionality. Basically, if you want to make some helper functions for editing Emacs Lisp code, you can use these three things to grab the text of whatever's under the cursor and then use it, maybe evaluate it or do whatever you want with it. It can also find URLs and emails using patterns, and it can find file names as well. And this last one actually is the one that we care about the most for our purposes in this episode, because we want to search through the file and grab the file names for the files that are being written out from the org file. So here we're going to use thing@point, and we're going to ask it for a word. So that first parameter of thing@point basically is the type of thing that we want to get at the current point location in the buffer. So I'm going to use Control X, Control E here, and it's going to return nil. But actually, let's run it here in the evaluation area, basically thing@point word. And here it gives me point, but it also gives me all this fontification information. So basically, you can use the T parameter as the second parameter to get rid of that if you don't want it. So I'm going to run that one more time, and then put T at the end. So now it gives me the word point. And the reason why it uses only point is because Emacs considers point a word, and it doesn't include all the other text with it because the hyphen doesn't consider it, it's not considered part of a word, basically. You can change that information, but we're not going to actually show that today because it has more configuration needed for it. Same thing for a sentence. So let me actually put my cursor right here, and I'm going to run thing@point with sentence instead, sentence. Now it gives me the whole sentence, basically. Try it on this with the whole file path, etc. So that's really useful. Similarly, you can use it for S expressions. So if I were to put it here and then run it with S expression, it's going to give me basically whatever would be part of an expression in Lisp. So it doesn't give me the whole thing, but it gives me whatever's under the point. I think if I put my point here at the parenthesis, it might give me the whole thing for that. Yeah, so it basically gives me the whole expression, excuse me, expression. So whatever your cursor is on, it will give you the whole expression at that point. Also, let's see, what was the other thing? Yeah, that's good enough for now, I think. So the one thing that's really interesting here is to pull the file name here. So it actually can detect this whole file name. And if I put in file name as the parameter, it will give me the whole file path here. So this is extremely useful if you want to do any kind of code that deals with file names that have been written in a buffer. I definitely recommend checking out the manual on this because there's more stuff that it can do. And also, if you look at the code, basically, you can find out even more things it can do. So definitely give thing@point a try. It's pretty cool, actually. Okay, so the last thing we need to know before we can start doing something really useful is how to search for text in the buffer. So there are two functions for this called search forward and search backward. And basically what they do is look for a string that you provide to it in the buffer. Based on where the point currently is, it's going to search forward or search backward. And when it finds it, it's going to return the point location where it was found. And the point location that it gives you is going to be either before or after the match string based on which function you call. So when you call search forward, it's going to give you the point right after where, right after where the match it found was. So if you say the search for the word, it's going to have the cursor right after word where it found it. However, if you use search backward, it's going to put the cursor before the word that it found. So just keep that in mind when you're using these, because it's not necessarily obvious at first what will happen. All right, so I'm going to use search forward and look for the word ways, and it's going to move the point to wherever it finds ways in this file. Control X, Control E. And now it jumped down to the bottom here on the slide where there's the word ways, basically. So it found that, and it did put it at the end of ways. So let me run that one more time just to make it obvious. Control X, Control E. And now you can see the cursor is here right after ways, like we talked about before. Same thing for search backward. I can use Control X, Control E. And it just searched itself because it's found the string for itself inside of the call of itself, because we're running it in the same buffer here. Obviously, if you're running this against code that's not in the same buffer as the code, then you will just find the string. It won't put it at the same location, but that's what happens here. So if you want to avoid, or if you want to find like the second or third result in the direction of the search, there is a parameter you can use that's like at the very end of the list of parameters called count. So there's two more parameters in front that you want to set to nil and t, and then you give the count parameter. So here, I'm going to say count of 1, which is basically the default behavior. Control X, Control E. It's going to find inside here by going backwards. However, if I say I want to find the third count of this, it's going to skip this one, and it's going to skip this one. It's going to find one up here, basically. So I'm going to run this code, and then the cursor will jump to here on this instance of inside, because I said I want the third result of that match, basically. So the other parameters, the first one is called bound, and it's basically a pair of point locations for the start and end location within which the search will happen. So if you want to constrain that search to a sub-region in the buffer, or a region in the buffer basically, you can use that parameter for that purpose. And then no error, which is also very important for automating searches. If you set it to nil, which is the default value, and you run search forward, it will return an error. It will throw an error if it doesn't find that. So let's actually test that out here. I'm going to say search forward foo, because I don't think foo is in this slide. I'll use Control X, Control E. It's going to give me an error. However, if I say nil for the bound and say t for no error and run it again, it's going to return nil. So basically, it will just return nil whenever it doesn't find a match. And this is often what you want to do whenever you are trying to use this programmatically. All right, so there's other ways to search inside of buffers, including use of regular expressions, and you can use that to extract text from matches. But we're going to cover this in another episode because it's a whole other topic in its own, and it's kind of complicated. So we'll skip that for now. All right, now we can finally do something useful. We can start to implement some of the code that we need for this functionality that we want to implement. So let me make sure that this is readable. I think it's fine. Okay, so what we're going to do here is write some Emacs Lisp code, or look at some Emacs Lisp code that I already wrote, which searches for the tangle properties on org source blocks so that we can extract the file path. Now, let me just illuminate what that means for a second. I'm going to go to my desktop.org file, and I'm going to find a tangle that has a file path on it, like let's say this one. So for any code block that's going to get tangled out to an output file, you're going to have basically what type of file it is first in the begin source block, but then you are going to say tangle, and then the file path right after that. So what we want to do is find every instance of tangle in this file, and then grab the file path after it. That way we know which files are being written out in the buffer. Now, obviously, this is not the safest way to do it because there's ways in org mode for properties to be inherited and lots of other things like that. So we're not going to worry about that right now. We'll deal with that in another episode. But for now, we're just going to do a simple extraction of information based on searching for tangle and then getting the file path right after it. And that's going to work in most cases, I think. Okay, so here we are defining a function called dotcrafter scan for output files. And we are going to put 2 hyphens here because what we want to indicate is that this is a internal function for the purpose. So for the purpose of the package itself, and we don't want to let the user call it, or we don't want the user to think it's something they should call. So we're going to use 2 hyphens here because this is an internal function for the package. And it's also going to take an org file as the parameter. And when we do that, we're going to create a let expression that defines the output files list, which we're going to add to progressively, and then the current match. So we're going to store whatever the current match is so that we can use that in our while expression to find the ending point basically for the loop. So we're going to use the withCurrentBuffer function as we saw before, and then we're going to load up that file or that buffer basically. We're going to try to find the buffer for that file. And once we have it, we're going to use save excursion to save the location of the point currently in that buffer before we start moving it around. And then we're going to move the point to the very beginning of the buffer, because what we want to do is catch every single instance of :tangled inside of the file. So to do that, we have to move that point back to the beginning just in case the user has it in the middle of the file, end of the file, whatever. So we're using goToChar point min here. However, we could use beginning of buffer if we wanted to. It's basically the same thing. So, actually, no, it's not the same thing. If it's narrow, then we probably do need to use beginning of buffer. So that's something to keep in mind there. All right, so while current match. So we're setting up a while loop here, and we're looking at current match to see whether it's nil or not. We're going to stop the loop whenever there's not been a match. We set current match to t by default so that the first pass of the while loop is allowed to go through. And then what we're going to do is set the value of current match, this local variable current match, to the result of search forward in :tangled space, because we want to make sure that we move the point just ahead after where that :tangled is so that we can extract that file name using thing at point. And we're going to use the no error parameter so that it doesn't throw an error whenever it doesn't find a match, because we know that at the very end of the file we're not going to find a match anymore, and we want it to return nil so that this while loop will break. So now we check to see if there's a current match before we do the next step, which is to basically grab that file name at point using thing at point, file name t, to get the file name without the properties on it, basically. Store that into the output file variable. We're creating another let expression, another local scope to store this output file. And then we're going to look to see whether an output file was given or found, and whether it's the value no or not. So basically we're using this unless to say, unless the statement is true, run what's inside. So we're looking for no, because you can actually say :tangle no to make it so that a particular source block does not get tangled out. So we want to skip any of those because those don't matter, obviously. They're not being written to a file. So this unless basically just says, if there is an output file that was found and is usable, then run the code after this, which is basically to update the output files list to add the output file to the very beginning. We're using cons for this. So if you remember from, I think it's episode 3 of the Emacs Lisp series, cons basically takes a list and tacks on a single value to the very beginning of that using the whole list pairing approach. So this is just a simple way to add an item to the beginning of the list. So we've saved this output files, and for each result, basically, or each match we find, we're going to keep accumulating that list of output files, and then at the very end, outside of that withCurrentBuffer expression, we're going to basically return the output files value from this function. So this whole function is going to return a list of the output files that were found inside of that org file. All right, let me evaluate that really quickly. So now we have this let statement. We're going to use this for testing purposes. So we're going to say output files is an empty list, and we're going to do a loop over our .crafter org files, which is emacs.org, desktop.org, systems.org right now. And we're going to basically concatenate whatever the current value of output files is with the result of calling .crafter scan for output files with the expanded file name path of that org file. So basically, for each of the .crafter org files, we're going to expand the path to be the full path, and then we're going to run it through this function we just talked about above to get all the list of output files, and we're going to concatenate all of them together to have one big flat list of all the output files across all of those org files. So let me run this really quickly and see if it works like we expect. All right, so the result is a list that is so long basically that it can't even be displayed all the way, but you can see that it's all of the output files that have been listed in all the tangled blocks inside of those org files. So finally, we've got the first part of the functionality we need implemented by basically scanning all those files for the output files. That's great. Okay, now we can talk about inserting text, because the next step in this whole process is updating our .gitignore file to have this list of files so that they can be ignored from Git and not be checked into the repository. So now we're going to talk about how we can insert text into the buffer at the current point. You can use the insert function for this, and also the insert care function. So the insert function will insert, basically you can give it any number of parameters you want. They can be characters, they can be strings, they can be objects, etc. And it's going to insert the string representations of those into the buffer at the particular point. The insert care function is a more low-level function where you basically give it a single character to be inserted. However, one interesting thing you can do with that is to basically say how many instances of that same character you want to insert. So basically, if you want to insert a line containing 20 hyphens, you can do that very easily with this function. So I'm going to use insert here to insert this nice little wonky face. So I use Control-X, Control-E, and it actually inserts it right after my cursor in the buffer. So it just shows you that you can insert directly where you are in the current buffer. Same thing with this insert call that has a new line string. It has a another string. It has two characters. This being, I think it's a white space, and then a new line, and then another string. So if I use that, Control-X, Control-E, then basically it writes this as Sparta on the next couple of lines. So basically you can see that you can put any number of things into that list and it will write them all out in sequence. And also we can do insert care with a hyphen with 20 characters like I mentioned before, Control-X, Control-E, and then it writes out 20 hyphens. So that can be useful if you want to do some sort of ASCII-based user interface or writing out some tables or whatever. You can use this to write all those characters out the way that they need to be written. So there's a couple of manual pages you can take a look at to get more information on doing that, and that might be pretty useful for you. All right, so now let's have another example how we can update the gitignore file based on the output files that we found before. So what we're going to do is first, what we need is some way to let the user have their own gitignore file, and then we add extra things to it so that we can manage those list of files that need to be automatically managed. So maybe the user has other files they want to ignore in the repository, and they want to be able to maintain that themselves while still having the automatically managed list. So to do that, we're going to define a variable containing a string that we use as a marker in the file, basically to say, at this point, when you see this text string in the file, anything after that is automatically generated and is managed by the dotcrafter package. But before that, anything before that is managed by the user, and they can put whatever they want there. So we're basically just looking for where this line is in the file, and then after that is what the package owns. So I will evaluate that just so we have it. And then we're going to define this dotcrafter update gitignore function. And what it's going to do is hold on to a list of output files that it's getting from calling against all of these files. Basically, what we're doing is taking that function or that do list that we had before to get all the output files, and we're turning it into a function now and adding some extra behavior. So what you see here is basically what we had before, this do list. setQ output files, we're appending the output files with the output of dotcrafter scan for output files. So that's exactly what we were doing before in the previous example. However, the difference now is that we've added some extra behavior for dealing with the gitignore file. So we'll start from that point. So now we are creating another local scope to have the expanded gitignore file path that we can use in the further functions. And we're also going to use with current buffer again to get a buffer for the gitignore file, because the user may actually have their gitignore file open as a buffer. So we want to make sure we edit that same buffer because it may have new contents based on compared to the file that is on disk. So once we have that buffer open using the same get file buffer or find file no select, we're going to use save excursion to save the point wherever it is, because that user may have that file open already. And then we're going to move the point to the beginning of the buffer because we want to make sure that we're searching for that marker string from the beginning of the buffer, wherever the cursor is in the buffer. So now we're going to use another OR statement here. And in fact, I think I have an extra prog in that's not necessary, but we're using this OR to execute one of these two things. So the first one is to search forward to see if we find the marker. So this is basically going to put our cursor after that marker in the file if the marker was found. So basically, we're going to use that variable that we had here, and this could actually be changed by the user. The user could change it to whatever they want, which is kind of nice. But we're going to use this pre-made string, basically, and search for it. Now, if we find it, the cursor will be put after it. If we don't find it, then this OR expression is going to drop down to the next thing, which says move to the end of the buffer and then insert that string so that we now have that marker in the file. And we're going to add an extra new line right before just to give it some extra space. So now, in either of these cases, either we found the marker that's existing in the file or we've added a new marker in the file, we're going to loop over that list of output files that we got from calling .crafter scan for output files, and we're going to add each one of them to the file using insert, using the output file path and the new line. So we're just going to have a list of files basically added to that file. So let's see if it works. I'm going to use Control-X, Control-E on this whole function definition, and then I'm going to call it. So .crafter update dash dash. This is another internal function. So dash dash update gitignore. And now it says nil. Let's actually go look at my my gitignore, my .files repo. .files.gitignore. And we can see if we scroll down that there's actually generated by dotcrafter.el and a whole list of files here. So that's great. But one thing we notice here is that this file is modified. It hasn't actually been saved yet. So I can save it right now myself, but it's something that we actually need to add to the code before we can actually call this done. So I'm going to jump back here. One other thing we're going to do, actually, let's actually do it right here in the file so we can see that it works. I'm going to run this again and see what happens. So I'm going to run in the eval area, in the echo area, basically. I'm going to run .crafter update gitignore one more time. All right, so it seems to have run. It seems to have changed the buffer, and it did not add a second marker line. However, it seems that it has added a duplication of the same set of files that we already had before, and we don't want that. I mean, it doesn't really matter because Git's going to do the right thing anyway, but we don't want to create a mess and just keep adding the same list of files if we keep running this function. If I go to the end of the file and do this one more time, you'll see that it adds it all again, basically. So the number of lines in this file right now is 171. If I run it, it's going to be 215. So we basically added a whole bunch of lines to this file for the same things over and over. So what we need to do now, basically, is clean that up. And in fact, I'm just going to leave this here so we can show how it works. I'll save this file, and I'll go back to the slides. So let's talk about how you can delete text. It's actually pretty easy. So what we're going to do is use with current buffer to set the current buffer to gitignore, and then we're going to call this delete region function. Delete region takes two parameters. One is the point location for the starting point to delete text, and then the point, whatever the ending point is for deleting text. So basically just delete this region of text between this point and this point. So what I'm going to do is say delete the region between point and point max here inside of the gitignore buffer. If we look at it right now, actually, I'll put the point right here, and I'll split the buffer so you can actually see what happens whenever deletion happens. So I'm going to execute this code with Control-X, Control-E. And then you can see that the lines at the end of the buffer from where the cursor currently is all got deleted. So this file is now cleaned up to some degree. So that was a very easy way to delete a bunch of lines in this file. You can even delete, just a word in the same line. It doesn't have to be the whole file. Similarly, we want to save the buffer. We want to make sure that our changes to the gitignore file get saved so that they get checked into the Git repository whenever the user checks in all of their files. So you can use the save buffer function to do this, and it's very easy. You just call save buffer, and the buffer will be saved to whatever file the buffer is associated with. Now, if you call this in a buffer that doesn't have a file association, it will probably prompt the user for a file to save to. So if I go to messages here and run save buffer, yeah, basically it asks me what file to save in. But since we're using a buffer that already has a file attached to it, then it should just save it no problem. All right, so I'm going to jump to the final example here. We're going to be cleaning up and saving the gitignore file. All of this code for .crafter update gitignore is basically the same. And the only differences are that we are adding the delete region here. So basically, after we've figured out where the marker is, the point currently is at the end of where the marker is. So we're going to delete from that point to the end of the file, basically, just to delete all the rest of the all the rest of the lines, basically. Then we're going to write out the lines again using this do list as we did before, and then we're going to call save buffer to save everything. So I'm going to evaluate this function definition, and then we'll go right here just to see it happening. I'm going to run in the echo area dotcrafter update gitignore, and we'll see that it updated that whole section, and it seems to be the correct list. So if I run it again, let's see, this file has 83 lines now. If I were to run this one more time, it's going to update everything, and then it's still 83 lines. And since the file list didn't change, it writes out basically the same contents. We also noticed that the file name is not read anymore because it actually saved that file. So now we are cleanly updating the gitignore file based on that list of files that we scraped out of our org mode files. I think this is actually a pretty cool example because it shows how you can do whatever it is you need to do using the inbuilt functions in Emacs, basically. Okay. So what's next? We've covered a lot today. This is basically like a 1 hour long episode. I'm sorry for the length, but hopefully it was actually really useful to see this sort of end-to-end example going through a lot of the different functions to do buffer manipulation. In the next episode, we're going to cover how to manage files and directories in Emacs Lisp. So this is actually something that will be useful for us because the dotcrafter package needs to help manage symbolic links between those generated configuration files and the location where they belong in the home directory. And we can also do some automatic scanning of files that are there and directories that are there to make sure that we're not overwriting things. So we're going to show an example of how to do that in the next episode to take this idea even further. And also, if you want to check out the final code, definitely check the dotcrafter.el repository that I showed you, because I'm going to check this into that repo after this episode is over. The final code is here, and it's actually a little bit more commented in case you want to look at it and understand what every line does. So definitely check that out in the show notes that I'm going to post as a link below to learn more about what the code does. So hopefully that was useful and entertaining and not too long, but I think it was necessary. So hopefully that was a good thing. So before we go, I want to say thank you to all of my sponsors. These people have decided to help sponsor the work that I'm doing on this channel to make all these Emacs videos and other videos about system crafting in general. And to be frank with you, their support means the world to me and actually is what keeps me going, because I don't want to let them down. And it just, I don't know, it just gives me this feeling that people actually care about what I do. So if you also want to become a sponsor of the channel, definitely check out the 2 links that I have below in the description for GitHub sponsors and Patreon. And there's also a link to PayPal if you want to do just a one-time donation. Yeah, so I think that we will probably see you. There may be a video on Wednesday. We'll see whether that happens or not. But if nothing else, we'll see you at the System Crafters live stream on Friday. We've been having a lot of fun with those, and I'm really looking forward to the next one. So make sure you subscribe to the channel and click the bell to be notified whenever we go live or when new videos get posted, just so that you're on top of everything. All right, so that was enough time for one day. So thank you everybody for watching. Leave comments below and let me know what you think. And until next time, happy hacking. Thanks a lot.